Good morning. Welcome to the mechanical separation processes. This is one of the courses that will be discussing about the solid handling. You have also thermal separation processes in which we discuss about liquid and gas and separations by different technique thermally. That will be also taught in this course, in this semester. So mainly we will be talking about solids, screening of the solids, size enlargement, size reduction, and handling of the solids. The topics of this course will be particle technology, mechanical separation, like sieving, characterization, particle motion, agglomeration, sedimentation, filtration, centrifuges, and cyclone separators. And at the end, we will be discussing about membrane separation. The grading or the assessment, we have two assessments, one at the midterm, 40%, and final, 60%. There is no homework or quizzes. However, we have some tutorials that some exercise will be given in those tutorials. And also I consider 10% for those who are contracting during the course and including in the discussion that we have with the students. So those will get also 10% bonus at the end, either at the midterm or final, depending on the exam grades. We have two books. Primary textbook is by Carlson and Richardson, Chemical Engineering Volume 2. And the secondary textbook is by McCabe and Speed, which is the Unit Operation of Chemical Engineering. The TA of the course is Rodo Siraj, with the email provided. So our lecture outline in this course will be about 14 chapters. Chapter 1 will be Introduction to Separation Processes. This is lecture 1 that will be given today. Introduction to particle solids, particulate solids, size reduction, storage and conveying of bulk solids, how we can store solids in the cellar and bins and other storage systems, how we can convey, how we can move solids, size enlargement, and then this is for midterm. So we have exam up to lecture 5 maybe. We have flow through the packed beds, filtration, cross flow filtration, gravity sedimentation, centrifugal separation, flotation and membrane in the final exam. Any question? Anybody has problem with the registration in the course? Okay, let's start with separation processes. In general, separation processes are very important in any process industry. They are integral part of the chemical or mechanical processes. They can either be an upstream or downstream of the process. So you may have separation at the beginning in the process or at the end. Also depends on the type of the process. For example, an effluent treatment stream separation process. Feedstock treatment is an upstream separation process. So feed before going to process must be cleaned, or the impurities must be taken solids before going to the process, to the reactor. So as you see figure, you have materials. They are the separation part first. All the impurities will be separated from the raw materials, and then it goes to the process. That may be a reactor or distillation column or any type of process. The products which are effluent air goes to the separation, and we recycle contaminants and provide clean air. Also, the solid or liquid products goes to the separation. We separate byproducts by distillation or any other type of separation processes, and then we have pure product. We have also some of the byproducts that will be recycled back to the system for the process. If you have effluent water as a product or byproduct of the system, so this also goes to the separation, and you have clean water output, and some contaminants may be recycled to the waste treatment. The separation processes may be primary separation, secondary separation, or tertiary separation units. Primary separations are coagulant or flocculant. Secondary separations are biological or oxidation pond. And tertiary separation unit may be polishing steps for effluents. For the separation of a solution, we may add heat and material to the process for separation. So it depends on the separation processes. So let's look at some of the examples of the separation processes. Distillation column, reboiler, which is separated by thermal energy. Evaporation heat exchanger also uses thermal energy. Separation processes. So one of the processes that we use in petrochemicals is thermal cracking of hydrocarbons. So ethane will be cracked to ethylene and propylene, which are the raw materials for the petrochemicals. So we have thermal cracking unit here. The petrochemical unit. That ethane as a feedstock, C2H6, coming to the unit as a gas, and then it will be cracked to produce ethylene, propylene, and some heavier C4H8, butylene, and so on. And then they have separation processes. Downstream of the process. So separation of C2H4 from mixture separation of C3H6 from the mixture and separation of C4H8, and all of these are distillation columns. But before sending the feed to the system, also we should have a treatment on the downstream, on the upstream of the system. So we have a cleaning, feedstock treatment. So C2H6, including some CO2 or SH2, will be going to the system, and then we separate CO2 and SH2 from the ethane and send pure ethane to the cracking unit, because these two gases are very harmful for the downstream processes. They are poison to the catalyst. So when C2H4 and C3H6 goes for polymerization for polyethylene and polypropylene, these are harmful to the catalyst in the reactor. So we have to clean at the beginning. So this is one example of the separation processes at the upstream and downstream together. So for any separation processes, separation processing. We need heat and energy and matter for the system. Heat and product. So we have energy and sometimes material for the separation. As an external agency. So this is called external agency. For the separation process. So, for example, for separation of solids, we use magnetic energy we actually have this one here. So when external energy is matter, which lead to separation, we have coagulation or flocculation. So we add some external material to the system like FeCl3 or CaO, calcium oxide, potash, aluminum. And these are going to neutralize the unit to have the pH of 7. And as an external agent, membrane-based processes are the examples. Okay, these are some examples. So let's look at this one. So when pH is greater than 7, then or potash, aluminum, which have be added to the mixture, bring the pH to 7. For pH less than 7, CaO, calcium oxide, is added. Bring pH 7. And this is normally used for textile effluents. Okay, let's look at categories of separation processes. Normally, we have two types of separation processes. This is also external agent for membrane-based processes. So broad categories of separation processes. One is equilibrium-governed separation processes. The other is rate-governed separation processes. Some of the separation processes are based on the equilibrium. The product streams are in equilibrium when with inlet stream. Equilibrium governs maximum limit of separation, for example, adsorption, distillation, extraction, which governs maximum limit of separation. Rate-governed separation processes are difference in transport rate of various species that dictates the separation. So the first type of separation is based on the equilibrium between the component of the mixture. The second is based on the rate. So different in transport rate is governed the separation, or is the main parameter for separation. Examples for equilibrium governed separations are distillation, is based on the difference in boiling points. So if you have two materials with different boiling points, you can separate them in the distillation column. Component of the lower boiling point goes to vapor phase earlier, and some vapors are condensed and sent back to the column for more purity of the product. So the example of this one will be the separation that we talked about as a downstream process. Here we had a mixture of C2H4, C3H6, and C4H8. The mixture is sent to some distillation columns to separate each from others. So the first one goes the first separation column to release the C2H4 from others. The second goes to the second column for purifying C3H6, and finally C4H8. So the mixture of the gases including CH4, CO, H2, C2, H4, C3, H6, and heavier components. Let's look at the heavier, let's name it heavier as a C4 plus. So we call it C4 plus, which are heavier components. Okay, they first go to the first column. So we have first distillation column. From the top of the column, we have C2H4, and from the bottom, we have C3 plus, anything from C3 and heavier. Then it goes to the second column. Let's sketch it and draw it in the smaller column to fit to the page. So we have C3 at the top, and then C4 plus at the bottom. Okay, so these are two columns. It may be another column downstream to separate C4, so I'm not going to talk about. And sometimes we have here, we have C2H4 and C2H6, and C3H6 and C3H8. So in this case, these are the on product or feedstock mixing with the product. So they come here as the C2, so C2H6, and then C3H8. So then these also should go to another column. For separation. So the bottom will be C2H6, the heavier, and the top will be C2H4. This one also goes to another column. The top will be C3H6, the lighter, and the bottom will be C3H8. So you see, for this type of mixture, you have about 4 columns. So suppose we don't have these here. If you have these also included, you need another column to separate those from the heaviers. So this is the first column. This is the second. This is the third column, and this is the fourth column. So these are separation by boiling point. So different boiling point for C2H6 and C2H4 can separate them to two heavy and light products. Also for these two and other gases. So this is the equilibrium-based separation that we have in thermal cracking separation unit. So here external agent is the reboiler, which supplies thermal energy to the column for separation. I didn't draw the reboiler here, but normally we have a reboiler at the bottom. So we boil the bottom product, and then you can send it back to the column again for separation. So the external energy here is reboiler, which supplies thermal energy to the column for separation. There is another type of equilibrium-based separation, which is absorption. So solute is transferred from vapor phase and absorbed in liquid phase. Since this is occurred in whole bulk of the solution, this is called bulk phenomena. Example is removal of CO2 from air and CO2 mixture using primary or secondary or tertiary amines. So we have a mixture of air and CO2, and to clean air from the mixture, you have to send it to different column, and you can wash it by amine solution to absorb CO2 from the air, and the air will be purified. Drying is another example of separation with thermal energy. So these are some examples of equilibrium-based or equilibrium-governed separation processes. The second type is rate-governed separation. First was equilibrium governed separation. The second is rate governed separation. So some species in the mixture have different rate transport, and then they can move through the system. So some of them will be plugged in the system, the others will pass the system, and you can separate them. The examples are reverse osmosis and osmosis. So concentration difference is the driving force for osmosis, and pressure difference is the driving force for reverse osmosis. So the pressure difference of the two materials, when you pass them through the reverse osmosis membrane, then causes this separation. But we are not going to talk about all of these above. Distillation processes will be discussed in thermal separation processes. In this course, we are going to talk about mechanical separation processes, everything which is based on the mechanics. So that's why fluid dynamic and fluid mechanics is the prerequisite for this course. So any chemical plants consist of upstream processes as a mechanical separation, which is pre-processing of raw materials, and unit operations like crushing, grinding, washing, filtration, and drying. Reaction is converting processed raw materials to product. Unit operations are oxidation, hydrogenation, and polymerization. Downstream processes include post-processing of products. So unit operations in this downstream systems are distillation, evaporation, extraction, and granulations. Okay, let's look at the unit operations. Unit operations are used to describe a physical and or mechanical procedure occurring individually or parallel to the chemical reactions. So they are used to conduct physical steps of preparing reactions or separation and purifying products or recycling and converted reactions. When you have a reaction, part of the products are the goods or the main products, and some are byproducts which may not be used in the market, so we have to recycle them back to the system. Okay, if you look at the mechanical unit operations, these are purely based on physical or mechanical forces. So there is no thermal energy involved here for the separation. It may be involved in preheating of the system, but it's not involved in the processes. The main mechanism of processes are physical or mechanical forces. These are gravitational force, centrifugal force, and mechanical and kinetic forces arising from flow. So definition for mechanical unit operation. These are the branch of science and engineering, and they are dealing with practice, description, the study of the processing handling, characterization, conversion, and use of the variety of particulate materials, both wet or dry, in sizes ranging from micron to centimeter. So in the mechanical process engineering, we are going to talk about the process handling of such solids, characterization of the solids, how we can characterize them in the size, density, and other parameters of the solids, conversion and use of the variety of particulate materials for wet or dry in sizes ranging from micron to centimeters. It is based on the general theory of concern with the physical properties of the finely divided substances, including powders, crystalline solids, granules, dispersions, and slurries, and paste. So this operation is a multidisciplinary field, including material science, environmental science, biomedical, aerospace and mechanical engineering, agricultural, chemistry, microbiology, and cell science, and pharmacy and medicine. So in all of these processes or topics, you need mechanical process engineering for pharmaceutical, for making the tablets, or even some solutions. You need this type of processing. Also for agricultural, for chemicals used in the agricultural, in aerospace and mechanical engineering, solid handling will be used. In biomedical, also some of the medication or solid handling. In environmental, we are with the particles, and also in material science. So all of the multidisciplinary fields are included in the mechanical process engineering or mechanical process engineering topic. List of industries are very wide. Use these particular processes are coal chemicals, explosives, ceramics, paints, food and beverages, glass industry, plastics, fibers, biomedical, fertilizers, and pharmaceuticals. In all of these industry, you may use mechanical process engineering. Mechanical unit operations can be classified based on the phases interacting as a solid operation and solid liquid operations or solid fluid operations. In the solid operation, the units are crushing, grinding, sieving, compaction, cutting, storage, and transport of bulk solids. So when you have two solids mixed together, to separate them from each other, you may have to use these operations. You may have to crush them, grind them, sieve them, and cutting to small particles, then store them, transport them as a bulk solids. In the solid fluid operations, we have filtration, sedimentation, centrifugation, flotation, and cyclone separators. So in this system, we have a mixture or a solution of solid and liquid together. So to separate solid from the solution of the solid and liquid, you have to send them through the filtration. That's what you do in the coffee maker. You have a coffee maker which has coffee and the solid particles. So you pass them through the filter, the solid will be captured by the filter, and then you get the pure liquid coffee out of the filter. Also in sedimentation, some particles are deposited at the end of the sedimentation, so you can separate the top part, which is liquid, from the solid. Centrifugation, you do it by centrifugal force in the special equipment, and you separate solid from the liquid. And also flotation and cyclone separators, which are used for gas, some gases, a mixture of gases together with particles, solid particles like ash. So we can separate ash from the mixture in the combustion flue gas by cyclone separators. Any question so far from the units? Okay, so unit operations involving particulate solids. Many of them are aimed to achieving separation of components, like separation of solids from suspension by filtration. So you have suspension of solid and liquid together. You send them through the filters, and by filtration you can get pure liquid out of the solids in the mixture or in the solution. Or fractionation of solids of wide size distribution based on size by gravity settling or differential settling methods like coal combustion. So in the coal combustion, if we want to use a particular size coal materials, we have to use this type of separation by fractionation of solid of wide sizes distribution and separate a specific size of coals and send them to the coal combustion. Separation of immiscible liquids by centrifugation or decanting, and separation of solids from liquids by centrifugation. So we have also a solution of solids with liquid together as a product of the reactor. When the product of the reactor are collected, they are a mixture of liquid and solids together. So to purify the products and to separate solids from the mixture or from the solution, you have to use centrifugation system or decanting. By centrifugal forces, you can separate solid from the liquid. Heat and mass transfer and or mixing of solids in the fluidized bed also is another example. Drying of solids, fertilizer granulates like urea in fertilizer industry are also one of the examples, and cyclone separators in the incinerators. Incinerators are the equipments, combustion equipments that you reduce the size of the waste by combustion. So the waste inside these incinerators. If you have the type of waste which are not used as a recycle, you send them to incinerator and burn them over there to get the energy out of the combustion and use the energy for a steam generation. So in the incinerator, the flue gas out of the combustion include some ashes, some solid particles, and normally we send them to the cyclone for separation of the ash materials and solid particles from the gases. This is also used, and so on. So these are the unit operation involving particulate solids. Some of the unit operations are grouped according to the mechanisms of transfer operations. So operation involving solids in fluids, operation with mixture of solids. So some operations are grouped according to the mechanism of transfer operations, like operation involving solid in fluids, operation with mixture of solids, and operations involving diffusion processes such as distillation, absorption, and liquid extraction. So these type of unit operations are grouped as according to the mechanism of transfer operation. So in the first category, we have operation involving solids in fluids. So we categorize them as a filtration, sedimentation. These are the separation processes for a mixture of solids and liquids together. There are some categories based on the mixture of solids. If you have two solids together, so it may be operated differently. And there are some separation processes or operations involving diffusion processes such as distillation, absorption, and liquid extraction. So for example, in the distillation column, we have the trays inside the column and the mixture of the liquid. You boil the liquid inside the column. We have the distillation column. So you send the mixture feed. The feed is a mixture of some components. So you send it to distillation column. So in the distillation column, we have some trays. It may be by tray or maybe by packed bed. But if you have tray distillation column, so in each tray, this goes to the reboiler. Part of it back to the column, and some are collected here as a bottom product. This is feed, this is bottom product, this is reboiler. And then the top part goes to the condenser. This is condenser. And we have top product as a D with XD composition. This is XP composition of bottom. This is XF composition of feed. And then part of it back is back to the column as a recycle. Okay, so in each column, in each tray, you have some cups here at the top with holes. So the gases goes up, the liquid is coming down, and we have equilibrium on the tray. For the separation in each tray. Then each tray perform the separation between the components of the mixture, feed mixture. So this is type of equilibrium-based separation. In the solid-solid handling, particles in solid-solid system can be separated according to the size, like sieving for relatively coarse particles and settling process for fine particles, or material type due to the density variation. Some materials in the mixture, they have different densities. So from the different density variations, you can separate them, or surface properties in solvent, magnetic separation, etc. So these are the type of solid-solid handling for separation of solid from each other. Many granular solids and particulates material can be found in variety of units of operation in industrial processes. As a raw materials, you have coal, rocks, iron, ores. As a finished products, fertilizers, cement particles, cosmetic powders, and so on. So some of the solids may be as a raw materials, so we can use them as a raw materials like coal, rocks, iron, ores, and some of the solid materials can be used in the final product like fertilizer, cement, cosmetic, powders, and so on. Thus, understanding the behavior of particulates or particulate materials and industrial powders is very much essential, especially from process point of view. Because solids are difficult to handle than liquids and gases, therefore, we need to have a special attention to handle the solids. Okay, so let's look at some of the characteristics of the particles. Do you have any questions so far?
No, doctor, thank you.
Okay. So now we look at powder and particle technology. Research on bulk and solid-state matters was neglected until mid-20th century. So until mid-20th century, we didn't have such a courses on such a material like mechanical process engineering. Because the need for such a course was not at that time, was not required. So research on solid mid. The first company, I guess, that used the mechanical separation was DuPont. So DuPont emphasizes that 60% of 3,000 products in their industries handled were in the form of solid particulates. As a company emphasize that 60% of 3,000 products were handled were in the form of solids particles, especially in the pharmaceutical industries. Thus, powder technology came out as an academic discipline in Germany during 1960 because they understood that they need such a discipline in the curriculum of the process engineering. So, powder technology as a academic discipline. During 19. Later, European countries like USA, Japan, Australia also started similar academic disciplines. But Germany was the first who adopted this course in the curriculum. Later, other European countries, USA, Japan, Australia, also similar. Discipline. Powder or particle technology is the branch of engineering dealing with the systematic study of particulate materials, both in dry or suspended form. So this is the definition for powder technology. You can say powder, particle technology, is a branch of engineering dealing with this materials, both in dry or so particle and powder technology comprise operations of crushing, sieving, characterization, storage, conveying, mixing, fluidization, agglomeration, and so on. These are the topics that we are going to talk about in this course. So particle technology, comprises operations of crushing, storage, conveying, mixing, fluidization, operation, it also filtration, centrifuge, thickening, decantation, fermentation. And we are going to study all of above processes in this course. Also, part of the materials can be studied under the material science. And these are finely divided and pulverized solids. Yes. Characteristics make them different from chunky solid. Hence, they cannot be studied under material science. Further, though certain go over, they cannot addressed by classic biology for their study. Research. So some of the materials are excluded from this separation process. Let's look at some of the distinctive properties of the solid state. Main distinctive property of solid state. So what do you think about the properties of the solid? Which property is the most important for the solid handling? Just name some of the properties of the solids. What are the important properties of the solid? Have you ever worked with the solid particles at home?
It's has a defined shape.
I didn't hear you. What did you say, Zahra?
The solid have defined shape.
Defined shape. So shape may be one of the characteristics, but this is not actually used for separation. We have more important.
The interaction between the particle is very strong.
Okay, so this is not used as a mechanical separation. We are going to mechanically separate the particles. So which parameter is used for mechanical separation of the solid particles? Which characteristic is used? If you want to mechanically separate particles from each other.
The size of the particles and the density?
Exactly. So who says that? Sharifa?
It's Hiba.
Oh, Hiba, yes. Okay, Azhar and Hiba. Yes, the size is the most important characteristic of the solids for separation. If they are at different sizes, you can very easily separate them by sieving. So we put them in the different meshes, and then by size, you can separate the solids from each other. There is another property of the solid which is very important besides size. Can you guess that one? This is normally used for sedimentation. Sedimentation, we said heavy particles are going down the vessel, deposit at the bottom of the vessel. So what's the property that brings those particles down?
The weight or the gravitational force.
The weight, but the weight, what's the property for the weight, which is included the weight? We don't say the weight of the particle. We say the mass over the volume. So what's that one?
The density.
The density, yes. So the density is another important properties that can be used to separate the particles. So we flow them maybe two types of particles between with different densities inside the liquid. And based on the liquid density and the particle densities, you can separate them by sedimentation, either by gravity or just by centrifugal force. So we can use that. So these are the most important parameters in the separation, mechanical separation processes. So particles of or properties, bring this under line out. properties of solids, large pieces from of particulate solid. Important properties of pieces solids would be mass per unit volume, homogeneous solids have the same density as the bulk material. So for the homogeneous system, we assume that the density of the bulk materials is the same as the density of the particles. But for the non-homogeneous or heterogeneous mixture, the density of the bulk changes. Is not the same as the density of the particles. Particles obtained by breaking of a composite may have various densities. As an example, for example, metal bearing ores, etc. So in some cases, the particles obtained by breaking up a composite solid may have various densities different from the bulk material. But normally we assume that for the homogeneous materials, the density of the bulk materials are the same as density of the particles. This is one of the important parameters. It's not the most size, but this is one of the parameters that are important in our separation processes. The second is hardness. And this is the resistance of solids to be scratched. Called hardness of the solids on the surface. Next will be fragility. represents how easy the substance may be crumbled or broken by impact. Can you give me some example of fragile particles, powders? You use them in your daily life. Have you used detergent powder for washing? So are they fragile or hard? Can we classify them as a fragile or hardness materials? Or let's say flour powder, when they come together as a pack. So when you touch them by hand, it will be changed to powder. So these are fragile. But sugar particles are not easily comes to the small pieces. So this is maybe hard particles. So they may have a higher hardness or they may be fragile. Examples are gypsum, not fragile. Coal is soft and also fragile. Detergent powder is fragile too. So you can make the small pieces out of the particles. Okay, so let's look at another characteristic of the powders or particles. This is called tenacity. And tenacity is resistance to collisions, which is also different for particulate solids and the bulk material as well. So we call tenacity as a resistance to collisions. And the bulk as well. cannot be the same. Voltanicity of the bulk system may not be the same as the particles itself. And this is the resistance to collisions for different particles. Okay, so let's stop up to here and then we can continue the rest in the next lecture. Let's look at what we had in this lecture, just review, short review. If you have any question, you may ask. So in the separation processes, we divide them in two parts in the process. So if you look at the whole process, some of the processes or separation processes are at the beginning of the process before going to the reactor, and some of them are at the end for purification of the products. So you have a mixture of the products at the end, and then you separate them to have a specific product and then send it to the downstream units. So you may have the separation for the raw materials at the beginning. We call it upstream of the system. You have separation to separate impurities from the raw materials. As an example, we had CO2 and SH2, the poisonous gases inside the hydrocarbons, like ethane or propane. And then you have to propane, and then you have to separate them from the mixture of the hydrocarbons and then send them for thermal cracking, because these are the poison of the catalyst on the downstream units. So some of the separation units are at the beginning of the process, some are at the end for purity, and some are at the middle, like separation of clean air from the effluent air to get the recycled contaminants from the air, or from the water, effluent water for wastewater treatment. So you get part of the solids out and then send it to wastewater treatments. You may have a sedimentation unit at the beginning of the wastewater treatment to deposit solids at the first stage and then send them for the reactor for treatment. So we have primary separation, secondary separation, and tertiary separation unit, which are at the end of the process. So coagulant, flocculant are the primary separation, biological, oxidation pond, secondary, tertiary separation are polishing steps for effluents. For the separation of the solution, we may add heat and material to the process as an external agency. These are samples of external agents. So for distillation column in the reboiler, we use thermal energy. For the evaporation, also we use heat exchanger and then thermal energy to evaporate the liquid. This is one of the examples of upstream separation. So you have a mixture of ethane, CO2, and SH2, which has to be gone through the thermal cracking unit, and we have to treat them in the column, wash them with some solvent, amine solvent, to get rid of SO2 and SH2, and then send the hydrocarbon, pure hydrocarbon, to the thermal cracking unit. Then at the end, you have a mixture of hydrocarbons as the olefins and lighter hydrocarbons, which are the products of the cracking unit. So we send them for separation in the distillation unit or separation part. So we have some distillation columns. In the different distillation columns, you can separate each component from the others by boiling points. So as a separation process, we need external agency like heat or energy or material. For some of the separation processes, we need material also to add to the solution to change the pH of the system. And then by using those materials as a solid materials, we can separate the mixture from each component from the mixture. Broad categories of separation processes are equilibrium-based and rate-governed-based separation. Some of the separation processes are based on equilibrium-governed separation. So these are like distillation. So in the distillation column, you have equilibrium in each tray of the column between the gas and liquid. So you can separate by this equilibrium, and then lighter components goes top of the column and the heavier come to the bottom of the column. We use also adsorption in this equilibrium governed separation unit. Some of the separation units are based on rate governed separation, and this is because of the transport rate of various species. So if they pass through the membrane, some of them stay in the one side and the other goes to the other side of the membrane. And in this case, by rate separation, you can simply separate them, especially for two liquids from each other. So we have examples of equilibrium governed separation like distillation, which goes for the different boiling points in each distillation column. You can separate them, and you have examples of thermal cracking separation units. External agent here is the reboiler, which supplies thermal energy to the column for separation. Adsorption and absorption also is another example. Solute is transferred from vapor phase and absorbed in liquid phase. So since this is occurred in whole bulk of the solution, this is called a bulk phenomenon, like removal of CO2 from air and CO2 by solution of amines. Drying is another example. So rate-governed separations are osmosis and reverse osmosis. Mechanical separation processes also can be used in the downstream or upstream of the unit. Unit operations are normally used to describe a physical and or mechanical procedure occurring individually or parallel to the chemical reactions. So these are called unit operations. Mechanical unit operations are based on the gravitational force, centrifugal force, mechanical and kinetic forces arising from flow. So we can say this type of separation is dealing with practice, description, and study of the process handling, characterization, conversion, and use of the variety of particulate materials, both wet and dry, in sizes ranging from micron to centimeters. And it can be used in variety of multidisciplinary fields, such as material science, environmental, biomedical, aerospace, and mechanical engineering, agricultural, chemistry, microbiology, cell science, and pharmacy and medicine. And lists of industries are coal, chemicals, explosives, ceramics, paints, food and beverages, glass, plastics, fibers, biomedical, fertilizers, and pharmaceuticals. we have some, the mechanical unit operations are divided in solid operations and solid fluid operations. Solid operations are crushing, grinding, sieving, compaction, cutting, storage, and transport of bulk, solid, etc. Solid fluid operations includes filtration, sedimentation, centrifugation, flotation, and cyclone separators. Then we talked about each operation. This is normally operation based on the equilibrium, so you have to use external agency like heat in the reboiler, and cooling, also cooling water for the condenser, and so on. Powder and particle technologies are the research on the bulk and solid state matter. So it was not known until mid-20th century, and the first powder technology came out in the academic discipline in Germany in 1960, and then other countries followed this in the colloquium. This is sedimentation, agglomerization. Okay, so there's some characteristics or properties of the solid state. And some of the important ones are density, hardness, fragility, and tenacity. So density is mass per volume, hardness is resistance to solids to be scratched, and fragility represents how easy the substance may be crumbled or broken by impact, and tenacity is resistance to collisions. So when they collide to each other, they may be broken to small pieces. Okay, so this is the first chapter, which is based on the introduction materials for this course. So in the next chapter, we are going to discuss about particle characteristics. Any more questions? Okay, thank you for attending, and see you next week in the next lecture.